Hello everyone and welcome to this GTS NX webinar. My name is Ivan Mikhailov and I'll be delivering this presentation for you today. As probably all of you already know, GTS NX is our new generation geotechnical software, and today I'll talk you through some of the major features we've incorporated in it. Before we start, let me first give you a brief overview of how to use GoToWebinar. I know everyone can hear me well, as we've already checked that, but in terms of the screen, if you want to maximize the view, you can just click on the overlaying boxes in the top right hand corner. If your screensaver comes up, you can simply wiggle the mouse from time to time or just switch it off before we start. A few other things to know: if you want to minimize the GoToWebinar window, you can use the red arrow for that, or if you have any questions, you can use the chat box for this. We have a technical support engineer on standby to answer questions right away, or if we cannot cover some of the questions on the spot, we'll make sure to answer them via email after the webinar. Before we start GTS NX webinar, I'd like to make a brief introduction to our company, MIDAS IT. On the screen you can see some landmark structures which have made their mark on the world. All these structures have been analyzed and designed using MIDAS IT CAE solution packages. Because of our specialized structural analysis and structural optimization applications, MIDAS is recognized as world-leading engineering solution provider and distributor. A few words about our global network. We began our operations in 1989 and currently employ 530 developers and engineers. We have 6 branch offices in different countries around the world. On top of that, we've built a global network of partners and distributors. Situated in 40 different countries, they help us supply our engineering technology to the world, and our software is being used in over 150 countries. Just a quick overview of some of our key clients. More than 50 of the top 100 engineering companies in the world are using our solutions. AECOM, Arab, CH2M, Hill and Golder rely on our software for their projects. You can also see names like Mott MacDonald, Parsons Brinckerhoff and Jacobs. So, as I said, top engineers from around the world have chosen MIDAS. Just briefly let me mention the solutions that we have. We've provided CAE software packages for a variety of disciplines. We have a specialized solution for building and structural engineering, that is MIDAS Gen, and we also have a package for bridges and civil engineering, MIDAS Civil. In terms of geotechnical engineering solutions, we have products for both 2D and 3D finite element analysis. The star in this field is GTS NX, which will be the main topic of this presentation. Apart from the construction industry, MIDAS also develops solutions for mechanical engineering, which can be widely applied in design and manufacturing. And finally, I'd like to point out that we provide not only software, but total engineering solutions. You can take advantage of all our resources, like free online training for both basic and advanced features. Also, in-house courses with specialized training programs and web-based technical support are available to all our users. Overall, through these comprehensive solutions, we can enhance your technical capabilities and improve your work productivity. Now that you're familiar with our company and who we are, let's move to today's presentation. I'll quickly talk you through the contents of this presentation. First, I'm going to give you a short overview of GTS NX and the improvements that we have done in terms of software programming. Then we will move on to the actual application of the software in terms of geotechnical engineering. We're going to look at some of the improved modeling tools of the software. Then we'll discuss some of the new geotechnical analysis capabilities. And finally, we will look at the post-processing features of the software and how it can be applied in different projects to improve our work as engineers. Now let me start with a brief product overview. Of course, we should start with the question, what is GTS NX? Well, GTS stands for Geotechnical Analysis System, while NX denotes new experience, and this is the key phrase here. The software has been fully optimized for 64-bit platforms, which greatly increases its capabilities. It is equipped with specialized and unique features, which have been developed to expedite the modeling and analysis processes. With these features, you'll be able to generate high-quality optimal designs with the ease and efficiency you never imagined was possible. By making good use of the 64-bit platforms, the software has greatly improved the analysis speeds and capabilities. More powerful pre- and post-processors have been implemented, and significant improvement of the user interface has been incorporated to suit the user needs better. First, let's look at the interface of the program. There has been a complete facelift to the user interface from our previous GTS product. The program has been equipped with an advanced user-friendly modeling platform that enables unmatched levels of precision and efficiency. The different tools and functions in GTS NX have been organized in a convenient, logical way to provide a friendly working environment. The ribbon menu, work tree, context menus, multi-window display, all these features have been designed to maximize our speed and efficiency during everyday work. The ribbon menu has been organized to streamline modeling workflow. Analogous functions are grouped together, and the right-click context menu has been optimized to bring useful load and boundary condition functions to the tip of your fingers. Enhanced context menu minimizes mouse clicks required for modeling and makes the workflow easier and more enjoyable. Image tooltips have been provided to help you familiarize yourselves with the software and to make features more understandable. With the aid of guiding figures, even a first-time user can easily understand the different functions and options and how to use them. Another significant improvement is the ability to open different models in the same application and seamlessly work with all of them simultaneously. Now let me show you the new graphic user interface in the software itself. First of all, we have some new options for the visualization of the program. For example, we can change the theme and the background. Also, the software supports multi-language interface, which is convenient for the international users. Another feature of the new interface is the ability to open several models in the same software application. As you can see, there is different models in every window. With the multi-window feature, we can compare results between different models or different analysis procedures in the same model. This feature also allows us to continue working on other models while some are being analyzed. Next, as I mentioned before, we have incorporated the ribbon menu in the new graphic user interface. The ribbon menu is organized based on function and analysis type in an intuitive manner, so we can find the different tools easily. We also have graphic tooltips to provide intuitive description of how to use each function, which, as I said, can be very useful in the process of getting acquainted with the software. Also, analogous functions are put together under tabs in the dialog window to allow us to quickly switch between functions and increase our efficiency. We also have improved the context menus to fully optimize them so that relevant functions for the selected objects can be accessed easily. By simply right-clicking the mouse, we can call out frequently used features for modeling like mesh generation and applying loads. Now let's look at some of the major programming improvements. These can be classified in three main categories: new 64-bit framework, new automated modeling features, and new universal solver. The software has been optimized and fully supports 64-bit platforms. This has a significant impact on the scale of the models you can handle and the speed of the operations. Also, there is no limit on the number of elements for performing the analysis, and all the hardware resources can be used to model and run analysis. For example, in 32-bit platforms there is a limitation that we can use under 3 GB of memory, regardless of the hardware specifications. In terms of automated modeling, different functions and wizards have been introduced to make complicated 3D modeling seem easy. And the new solver, with integrated GPU support and various analysis options, makes impossible simulations possible, which allows us to model and analyze conditions much closer to the real world. Moving on to the practical work process, the general geotechnical workflow stays the same, but with GTS NX we can do this in several simple steps. We can import CAD entities to easily create realistic 3D geometry, then we can model our structures using the CAD features, apply load and boundary conditions, analyze the model and obtain results. But while the general process stays the same, GTS NX brings numerous small improvements in every step, which help us increase our capabilities and efficiency. For example, as you may know, in MIDAS GTS, it is sometimes annoying to generate shared faces between solids. But now in GTS NX we have the auto-connect function, which will automatically show us the shared faces for the solids we have selected, and simply clicking OK will define those and guarantee nodal connectivity after meshing. Additionally, the hexahedron-centered auto-mesh generation can guarantee very stable stress and strain results at the element face. Also, we can define analysis conditions like boundary conditions and loads automatically and run analysis with high performance 64-bit solver. Then we can use the unique and powerful post-processors to extract the results we need. Overall, we can say that this new version only shares the name GTS of the previous, but every feature of the software has been improved to bring a new user experience. Now that we've covered the general improvement of the software, let's look at some specific modeling features of GTS NX. It is easy to become proficient in modeling in GTS NX with the CAD-based 2D and 3D modeling commands. GTS NX has various advanced modeling functions that will enable you to model even the most complex projects with unmatched levels of ease and precision. These functions enable you to effortlessly and intuitively make modifications to your 3D models and are especially useful for modeling detailed soil layers and surfaces. Geometry that would have required a significant amount of time to model in other programs will only take you a few moments to model with these highly specialized features. Another feature of the program is the terrain and soil strata generation. Project sites that contain complex contour surfaces can take hours to model with basic CAD commands. Typically, idealizations are made in the interest of time, which in turn leads to decrease in accuracy of the final analysis. GTS NX features a high-end terrain geometry maker that automatically converts topographic maps into editable surfaces. It is also equipped with a bedding plane wizard that enables us to model uneven soil strata with ease. We can directly utilize our soil profile by entering the boring log data for different locations. The program will then automatically extrapolate the changes in soil levels between the points to allow us to generate our soil layers. Now let me just demonstrate to you how the bedding plane wizard and the terrain geometry maker work in the software. So, starting with the boring hole data, in GTS NX we can easily generate 3D ground layers by importing the location of boreholes and inputting the borehole log data. We can directly import CAD entity including boring hole location in order to specify the location of boreholes, or of course we can just create the points manually. Then, using the bedding plane wizard, we can automatically define the surfaces for the soil layers. First of all, we can define the number of soil layers, and then by selecting each borehole we can input the boring hole data. After this, GTS NX automatically generates the interconnecting surfaces by interpolation. We can use the preview function to check our input graphically and then simply apply it in the model. Once we have the soil layers defined, we also need to generate the ground surface. This can be easily done using the terrain geometry maker. Here we can create highly irregular 3D surfaces representing actual ground topography by directly importing a topographic map. We can specify the area of interest and the number of sampling points to control the degree of precision, and the software will generate the ground surface for us. We can then save this surface as a file and import it in our GTS NX model. With the surfaces defined, we need a solid to represent the soil layers, generate a layers box and simply cut it using the surfaces we generated for the layers. You can see how quick and easy this procedure is, and it allows us to quickly generate accurate models of the ground at the site for our project. Now, moving on to the next features, I would like to introduce the auto-generation of co-phase between adjacent solids. Using this feature, we can automatically generate shared faces between adjacent solids and guarantee nodal connectivity after meshing and reduce 3D modeling time significantly. We also have the automatic imprint function, which can be used to automatically generate points at the locations where edges penetrate solids or planes. This can be very useful as it simplifies the modeling process when we have structural members penetrating into ground strata. Several modeling steps such as division, translation, deletion had to be followed previously, but now the modeling process has been drastically simplified, which brings a reduction in the time required and increases our productivity. It also helps beginners who are unfamiliar with geometric modeling to perform 3D modeling without failure. Next, I would like to mention about the compatibility of the program with other software products. Engineers who have their projects drawn in CAD often find that they need to redraw the entire project in the analysis software when they come to the point of modeling and analyzing their designs. GTS NX enables us to improve your CAD drawings directly into the program. This feature completely eliminates the need to recreate existing drawings in the program, thus saving us considerable amount of time and effort. Once the geometry is imported, there is a variety of different tools to fix geometric shapes. For example, where we have gaps between edges that should be connected, NX will remove these small surfaces and make the connections. And also GTS NX is fully compatible with other MIDAS softwares, so we can import model information directly from Gen, Civil and SoilWorks. We can transfer the entire structural data into GTS to obtain a full structure ground model for cell structure interaction, such as architectural structural foundation, ground couple analysis and bridge structural foundations, and ground couple analysis. In relation to geometric modeling inside the program, there are a lot of improvements in the Boolean operations, the geometric modeling robustness and the overall performance and speed compared to the previous versions of GTS. The GTS NX geometry kernel is based on Parasolid kernel, and with 64-bit pre- and post-processors we can easily generate and manipulate large and complicated models with more than 500-600 solid volumes without failure. For example, when we tried to create this first model in the old GTS, it took 20 seconds and there were 38 failures, but in GTS NX the model is created in 5 seconds without any failures. Similarly, the second model took 39 seconds and 5 failures in the old GTS, but in the new one it is successfully generated within 22 seconds. In other cases, like this simple geometry, even though both versions created the model successfully, the old GTS needed 89 seconds, while the model is created in less than 1 second in the new version. So you can see how much more efficient and powerful the new GTS NX is. Now let me discuss the auto mesh generation. In GTS NX we can generate mesh automatically for any complex geometry or intersecting volumes using the auto mesh feature. We can either use tetrahedral elements, or for smoother calculations of stress and pore water pressure at nodal points we can generate combinations of elements in our model using hexahedral, pentahedral and tetrahedral elements. And you can use either linear or quadratic elements. We also have the map mesh feature at our disposal. Using this feature, if the model has symmetry and permits generation of structural mesh, we can use map mesh to generate structural or regular mesh either for 2D or 3D geometries. Also, similarly to geometry functions, we can also use the 2D mesh to generate easily a 3D mesh. This is done using mesh protrusion functions such as uniform or non-uniform extrusion, revolution, etc. And of course, GTS NX provides automatic and manual options to control the size of the elements in our model. We can define edges or global sheets to restrict the element size at areas of stress concentration. One new powerful feature of GTS NX is that it incorporates a hybrid mesh generation function that creates mesh sets using an optimal combination of hexahedron and tetrahedron elements. Hexahedral elements, which as we all know produce very reliable results, are generated even in complex models. This kind of hybrid mesh is formed by generating hexahedral elements outwards, tetrahedral elements inwards, and pyramid ones as transition between the two. The main advantage of using hexahedron elements is that they provide comparatively more accurate stress results than tetrahedral elements, and the advantage of using tetrahedral elements is that they are more effective for modeling sharp curves and corners of complex geometries. GTS NX is capable of utilizing both tetrahedral and hexahedral elements without any significant loss in modeling or analysis speeds. In terms of speed, GTS NX supports multi-thread parallel mesh generation feature, which optimizes the mesh generation using the best combination of your hardware resources. The more the solid blocks, the faster the mesh generation becomes. In this slide you can see some examples of relatively large models that we tested, where the meshing was done up to 93% faster in the new GTS NX. Moving on to boundary conditions, in GTS NX various boundary conditions for all analysis types are provided. Essential boundaries such as constraints for ground in static analysis and damper or transmitting boundary for dynamic analysis can be defined automatically. By defining water level surface, the pore water pressure can be automatically considered in stress analysis. Time-dependent water levels can be defined to simulate rapid drawdown as well as gradual rise in water level due to rainfall. The change property function can be used to accurately simulate change in material properties over time during construction sequence. This function is useful for simulating the hardening of concrete as well as excavation projects in which soil layers are replaced by structural elements. In terms of load assignments, GTS NX can simulate various in situ loading conditions. We can define the general load conditions such as self-weight, force, pressure, temperature loads, etc. There is also a dynamic function database which includes a variety of code-based response spectra and time history functions. Additionally, custom functions for vibration, blast and seismic loading can also be generated. Also, the train moving load functions can be automatically generated by GTS NX by simply defining a load distribution to model the train and specifying the velocity. We can obtain the train moving load function automatically considering element size. Now I'd like to introduce some of our new construction stage features. When performing construction stage analysis, it is often necessary to create multiple models to analyze the effects of different design considerations. This process is made particularly cumbersome by the need to open a separate model file for each analysis case. GTS NX overcomes this limitation by its unique ability to have multiple construction stage analysis, to which we refer as construction stage sets, modeled in a single file. This feature makes it possible to directly compare different construction sequences and determine the optimal design for our project. It will also make file management easy and will make it unnecessary to redefine an identical construction stage, thus it will increase our productivity. Another powerful feature I would like to mention is the auto set, which you can see demonstrated on the left. With this feature we can generate construction stages based on the status show hidden in the work window. That is, we can simply hide selected elements, display specific loads and boundary conditions, and by a single click of the mouse we can save the currently active assignments as a construction stage. There is no more need to define analysis data per stage one by one using the drag and drop or the wizard functions. Even beginners can now easily define construction stages. Also, for every construction stage set, only the options that are relevant to the specific analysis type remain available, which will help avoiding user disruption and analysis errors. Okay, so next I'll discuss some of the improvements in the analysis procedures and capabilities of the software. Starting with a problem which many geotechnical engineers face, the use of multiple geotechnical programs and the need to learn the unique interface and features of each one of them. Even more inefficiencies arise when there is a need to perform various analyses for the same project. For example, dam and levee projects often require seepage, settlement, slope stability and seismic analysis to be considered. The same also applies to foundations and retaining wall projects that require soil structure interaction as well as stress deformation analysis to be performed. Most geotechnical problems can only perform one analysis types, which creates the need to tediously create the same model in several programs. With GTS NX you will no longer need to rely on several different geotechnical programs. Instead, you will be able to use GTS NX to perform any type of geotechnical analysis. It can perform both single and group pile interaction as well as complex tunnel analysis in either 2D or 3D. Linear static analysis, seepage, soil structure interaction, SRM slope stability analysis and a wide range of dynamic analysis applications can be done as well. Moreover, your efficiency will be greatly increased by the ability to run multiple analysis types on a single model file. Here you can see some highlighted analysis methods. I will explain about this in detail in the following slides. These advanced analyses are to simulate ground behavior as close to real world as possible. Starting from the basics, the element library. The element library of GTS NX includes various elements for structural and ground modeling. These elements are classified into the following categories: line, plane, solid and other types. In line type there are embedded truss, nonlinear beam element, as well as tension only and compression only elements. In plane type we can find plate elements for the shotcrete or lining, as well as gouging shell element for obtaining the member forces of solid elements. In particular, there is plot only dummy for only modeling in line and plane type element. Also there are interface elements used to allow slip, 3D pile elements, etc. Moving on to material models and functions, in GTS NX we have the following material constitutive models for simulating the behavior of soil. In addition to simulating isotropic and anisotropic linear elastic behavior, a comprehensive set of nonlinear constitutive models are included to represent the most realistic soil and rock behavior. There is linear elastic model having simple behavior, von Mises and Tresca model matching the structural behavior. Moore column matching the general soil, Moore column considering hardening behavior, Hook-Brown matching the rock behavior, and modify Cam Clay for the behavior of soft ground. Also, you can directly add your own ground constitutive model by using user-supplied material. GTS NX also provides various functions to apply nonlinearity of ground and structure. Especially unsaturated property functions are crucial in order to consider partially saturated effects for stress analysis. A few words for the analysis performance in GTS NX. All analysis types are performed by a single 64-bit integration solver. Improvements in the analysis efficiency have been achieved by optimizing data management. Based on multi-thread element computation, the solver will calculate the stiffness matrix by distributing the work between the cores, which will speed up the procedure as different parts of the model will be handled simultaneously. With in-core computing, the solver can detect how much memory is available in the system and use that first, and then if we run out of memory, it will save element matrix in the hard drive. Through this automatic procedure, analysis speed will increase drastically. Moreover, shifting from CPU to GPU can improve the speed up to 16 times. And in general, we are not only talking about analysis speed, but the overall performance of the software is increased. Improvements can also be seen in the pre- and post-processing procedures. And this high performance that we just discussed leads to the ability to tackle problems and models on a completely different scale. As mentioned earlier, by being optimized for 64-bit platforms, the new GTS NX can analyze large models with every analysis method. We no longer need to reduce the number of elements or construction stages in order to deal with memory problems. As we can see here, models with more than 3000 solid elements, which were out of reach for the previous version, can now be analyzed without any problem. Here we can see some figures showing how much more effective the new solver is. 64-bit systems will reduce the analysis time by more than 2-fold. With 64 bits and GPU support, the analysis can be reduced between 5 to 16 times, and the efficiency of case study and work will be significantly enhanced. The restrictions on output file size have been removed, and therefore handling a large model is no longer a problem in practice. Another significant improvement has been introduced to improve convergence of analysis. Nonlinear finite element solution is a method of converging the accumulated incremental solution from iterative calculations to the correct solution, and it is processed as shown in figure on the right hand side. GTS NX provides the automatic tangential stiffness update, which judges an appropriate recalculation point by considering the overall characteristics of the nonlinear problem, such as conversion characteristics or determination of divergence. When the solution is determined to diverge, the nonlinear analysis solution is judged to have possible diverges, and necessary measures are taken on the algorithm, such as recalculation of the stiffness matrix or load bisection. Load bisection is applied when the increment of the current load step is too large to obtain a convergent solution, such as when the solution diverges or when the number of required iterative calculations is larger than the user-defined maximum number. By restarting the iterative calculation through bisecting the current load increment, an inappropriate load increment size can be dealt with in a flexible manner. GTS NX performs this load bisection automatically until the user-defined maximum bisection level is reached. Of course, it is always better to have an appropriate load step defined in the first place, but this feature can help us solve our model instead of receiving non-convergence in the last step. Back to some modeling features of the software, a few words about meshing. The new important part in meshing generation is the node connectivity between adjacent elements. If the nodes are not connected, errors can occur during analysis. By applying contact elements, the adjacent elements of non-coincidental nodes can behave as one body. This makes modeling convenient and analysis economic. Additionally, the new hybrid meshes, which optimize the use of quadrilateral-based meshes, provide more stable analysis than triangle-based meshes, especially at boundaries like excavated surface. So, combination of hybrid mesh and contact elements enables us to perform analysis even of very complicated models without failure. In this slide we can see a common case when this comes in handy. Depending on the shape and composition of the geometry, sometimes it might be hard to make co-faces between solids. In such cases we can generate a mesh for each solid separately, then simply apply contact element to connect the nodes of the different meshes and obtain continuous results. You can see on your own the potential usefulness of this feature. Moving on, the next new feature I'd like to mention is the automatic water pressure. Geotechnical issues in the field are mainly caused by water, like dewatering excavation, degree of saturation, seepage force resulted from head differences, and so on. GTS NX can handle these issues not only in static but also in dynamic analysis. Water pressure can be considered in stress analysis automatically based on the height of the water level, including partially saturated effects. This allows for the soil behavior to be estimated very accurately through a variety of analysis functions. Furthermore, accurate effective stress results can be obtained from the actual water level. Here we can see some examples of how the pore water pressure is acting on the ground. We can now define water levels not only as plane but also as 3D water surface. This can be done very easily by just selecting an existing surface. Also, water pressure and seepage force caused by the difference of water level at the element face can be automatically computed and reflected in the analysis results. Moving on to some of the analysis improvements that have been introduced. In case of load stability analysis using strength reduction methods, we can now define not only more column models but also other nonlinear models like Drucker-Prager or modified more column model. Also now the arc length method can successfully trace the equilibrium path even when the static equilibrium state includes an unstable region. And additionally, with the automatic load bisection method, the accuracy and analysis speed increases drastically. Next, I'd like to say a few words about a completely new analysis feature, the fully coupled analysis. When water level is defined in the model, fully coupled analysis must be performed to consider the consolidation and seepage stress interaction simultaneously for the duration of the construction, just like in the actual ground behavior. These are some simple examples of problems that can be accurately analyzed only by performing fully coupled analysis. In this type of analysis, all kinds of seepage boundaries such as nodal head, flux and review can be applied during stage stress analysis. This allows us to simulate methods like suction drain, or for example we can check the displacement or member forces including variation of water level with time in construction stage analysis. Some other options for advanced analysis are consideration of water level when performing eigenvalue, linear time history or nonlinear time history analysis, also nonlinear time history dynamic analysis with consideration of nonlinearity of materials. We also have the option for nonlinear time history dynamic analysis combined with strength reduction methods. For example, we can perform evaluation of massive landslide hazards areas and seismic safety analysis. Additionally, we can now define various time step conditions. We can adjust the time step for each desired range. And also we can now perform initial stress analysis considering self-weight, and we have the capability to evaluate dynamic behavior. So we can obtain combined results from the static and dynamic effects directly. We no longer need to combine them manually. As I mentioned in the previous slide, we now have the option for nonlinear dynamic analysis, which is an entirely new feature. Typical areas of application of nonlinear dynamic analysis can be soil structure interaction behavior, evaluation of embankment stability under dynamic loads, crash loads, structural response assessment due to seismic loads, and liquefaction evaluation. In this graph, we can see a comparison between linear and nonlinear analysis. As you can see, the nonlinear analysis brings some significant improvement to the accuracy of the results. This is because soil behavior is mostly plastic, and so the nonlinear dynamic analysis renders more realistic results. And as we already mentioned, nonlinear seismic analysis can now be combined with slope SRM analysis to evaluate the seismic behavior of the ground and whether an earthquake will cause a landslide. And to close this part of the presentation, I'd just like to mention that in order to demonstrate the performance and capabilities of the new GTS NX software, numerous benchmark problems that are widely recognized and accepted as standard problems for testing the performance of general finite element programs have been solved. These include benchmark problems from the suite of the National Agency for Finite Element Methods and Standards at the National Engineering Laboratory in Glasgow, UK. Also, many problems have been selected from refereed journal papers and technical publications, as well as books from established authors. Problems have been selected to cover both static and dynamic, linear and nonlinear, as well as seepage and consolidation analysis. Moving on to the next part of this presentation, here I'll discuss some of the key post-processing features of the software. First, a few words about the graphic output. GTS NX features a powerful post-processing engine that is capable of converting complex models into simple cross sections, clipping planes, and contour line representation. We can choose from a wide array of display options that have been designed to meet a variety of project needs and preferences. The post-processing engine can automatically generate contour display models for key results such as displacement, deformations, skin friction, bending moment, and axial loads. These models provide excellent graphical display of our results that will enable us to quickly and efficiently identify the critical points of the project that need to be included in the final report. Some of the key new features, which you can see here, are the 3D to 2D wizard, the 3D flow path animation, and so on. In terms of extraction and visualization of results, the program provides a number of useful features. A typical difficulty of finite element programs is filtering through the substantial amount of analysis output for the result that you need to find for your report. GTS NX overcomes this difficulty through intuitive filtering functions that enable us to automatically sift through large quantities of output and extract the results that we need. For example, we have the multi-step line or surface display, where we can conveniently display results in 2D or 3D. We can also use clipping planes to reach the areas of interest and print those results. And of course, there are many other features to help us assess the results of the analysis. So now I'd like to demonstrate you some of the new improvements of the post-processing features of the software. Starting with contour and legend, this option allows us to present any analysis result in an intuitive manner. Choosing from the results tree, we can directly check different results, keeping the display options. Another feature is the probe and extract tool. With this, we can easily get maximum or minimum result values, or if we are interested in a specific node or element, we can simply click on it and a result tag will appear. Next, I will show you our clip and slice plane feature. When we are interested in some results inside a solid, we can inspect those in the 3D model by using any cutting plane. We simply activate the clip and slice plane tool and choose a plane on which we want to check the results. Cutting planes can be easily defined in standard directions or by using specific input by the user, like based on 3 points or an element face, for example. And we can also activate more than one cutting plane simultaneously and we can check the results in the progress of the construction stages. Another new feature is the 3D to 2D wizard. With this feature, we can obtain results from inside solids using any cutting plane. The software automatically interpolates results for the plane using close-by nodes and highlights in red the zones for which a value is available. Next, I'll quickly show you the ISO surface feature. It can be used to determine the distribution trend of 3D analysis results. It is very helpful to easily visualize the distribution of different effects in 3D. And finally, I'd like to show you the new animation feature for the flow path results. Here we can define different flow paths of interest, and the software will represent the results in 3D, showing the seepage velocity as animation. And of course, as we said earlier, we can use the multi-window display to look at various results simultaneously. And finally, I'd like to talk briefly about a brand new feature of the software for results output. The reports of finite element analysis can take just as long to create as the finite element models themselves. This is due to the wide range of results that are generated for finite element analysis that consist of a wide variety of contour models, spreadsheets, and graphs. GTS NX features a groundbreaking new feature that enables us to generate reports in 3D PDF format directly from the post-processing results menu of the program. This feature eliminates the need to tediously use print screen and copy-paste functions to generate reports in the form of Word documents. The result extraction functions enables us to seamlessly select 3D contour models of interest, alter the viewing size and angle, and add nodes, dimensions, and corresponding graphs and spreadsheets as needed. In addition, after analysis, we can print out the summary of analysis result as text file. And from dynamic analysis results, we can check decibel results converted from displacement, velocity and acceleration automatically for measuring noises. Moving on to the final part of this presentation, I'd like to talk about the application areas of GTS NX. GTS NX is a proven numerical modeling software used by many international geotechnical companies. Here we can see selected applications which have been modeled in GTS NX. The program has two wizards for tunnels and anchors. The tunnel wizard can model tunnels having regular pattern and define excavation methods such as full face cut or bench cut. We can choose an excavation direction from one end or from both ends simultaneously. For each case, load relaxation can be considered by applying load distribution factor. When we're dealing with slope stability, in GTS NX it can be analyzed with trend reduction method, which is based on reduction algorithm of soil parameters simultaneously until failure occurs. And we can obtain the critical factor, which is the minimum factor of safety at which failure occurs. When we're dealing with foundations, we can analyze driven or bored piles behavior either in isolation or grouped arrangements subjected to any combination of vertical, lateral and eccentric loads. We can estimate the bearing capacity of various types of foundations as well as differential settlement due to active load sets. For the analysis of excavation and temporary structures, we can simulate excavation sequence considering temporary supporting structures for deep excavation. We can also take under consideration existing nearby facilities such as subway tunnels and stations, buried conduit or box, and so on. We can also account for changes in earth pressure and groundwater level. When we deal with soft soil or embankment, we can calculate the dissipation of generated excessive pore water pressure in the model due to surcharge loading process. We can extract graph representation of results for time settlement behavior of various types of surface profiles. Or we can look at the acceleration of soil consolidation using vertical drains in 2D or 3D. For seepage, we have two types of analysis for both steady state and transient flow based on Darcy's law. Steady state and transient seepage for tunnels, dams and slopes, and stress seepage semi-coupled analysis for the analysis of waterfront systems, dewatering and other similar problems. And finally, I'd like to show some projects in which GTS NX could be applied with great benefits. For example, in projects like the Dubai Tower, which is approximately 80-story high-rise tower, or the Palazzo Versace and D1 Tower in the United Arab Emirates, GTS NX with its powerful capabilities would be of great benefit. In such projects, full 3D finite element modeling is needed in order to completely understand the behavior of structure and ground. GTS NX will help with its flexibility and capabilities to cover many complex analysis aspects in a single model. Other cases in which GTS NX would be of great benefit are projects like the King's Cross Station in London, UK, or the Odeon Tower in Monaco. In such projects, careful analysis of the effect of new construction on existing adjacent buildings needs to be performed. With these powerful modeling and analysis capabilities, GTS NX would allow for assessing both the new structure as well as the interaction with the surrounding ones. Overall, GTS NX can perform all types of geotechnical analysis in order to cater for the requirements of any project. We have now come to the end of this presentation. If you have any questions, you can always contact us using the emails on the screen, or if you'd like to try GTS NX by yourself, you can download a free trial version from our website. I'd like to thank you for your attention. I hope you find the information presented today useful and the features of our new GTS NX impressive. We're looking forward to hearing from you again, and thank you for your time.